All right, so let's take a look at these problems. I think I'll do the first four on the same video because they all have the same directions. Um, it wants us to find the values for the six trig functions for the angle in the standard position whose terminal side passes through the point. All right. So -3, -4 is a point down here in the third quadrant, and they want me to we always make our triangle with the right angle with respect to the x-axis. Okay, so I've got oops, 3 to the left and 4 down. I'm in reference with this triangle. 3, 4, 5 by the Pythagorean theorem. This is going to be 5 because 3 squared plus 4 squared is 25, and the square root of 25 is 5, and they want me to work with this angle. Okay, so we have to be careful here. When we find the sine of theta, if I'm just using positive distances here and not really thinking about the coordinates of this point being -3, -4, I have to be really careful because the sine is the opposite leg of the hypotenuse. 4/5 is what I would get. But that would have a sign error, and sine I mean SIGN, because remember that we define sine of theta to be the y coordinate divided by r, where r was always positive. So it is probably smarter for us to actually sit there and not say that we have negative distances, but to use negative values here, to use the x and y coordinate when we come in for our trig ratio. So when I find the sine of this angle theta and I use the opposite over the hypotenuse, we always use a positive hypotenuse, and we call that r, and r was the square root of x squared plus y squared from the Pythagorean theorem. All right, so for this sine, I get -4 over +5. For cosine of theta, the adjacent leg over the hypotenuse, -3 over 5. The tangent of theta, well, the opposite over the adjacent, -4 divided by -3, the negatives cancel, and I just have 4/3. The reciprocal, we wanted all 6 trig functions. The reciprocal of sine is cosecant, and this will be -5 over 4. The secant is the reciprocal of cosine, and this will be -5 over 3. And the cotangent is the reciprocal of tangent 3 over 4. Or you could go cosecant is the hypotenuse over the opposite leg. The secant is the hypotenuse over the adjacent leg. The cotangent is the adjacent leg over the opposite leg, and the negatives cancel. Anyway, for problem 1, that's our 6 answers, and the sign SIGN is important. The fact that sine, cosine, secant, and cosecant are all negative values are very important. All right, let's move on to the next one. This time, we're over here in quadrant 4. If I go to the right 4 and down -6, there's my point. When we draw our triangle, we always make the right angle with respect to the x-axis, and our theta is always right here, drawn between our hypotenuse and the x-axis. So if I'm going to the right 4 units, if I'm going down -6, I'm going to use that. Now, as far as the hypotenuse goes, it's always positive, and 4 squared plus 6 squared, what do we have? 16 plus 36, 16 and 30, 52, and the square root of 52 is 2 times radical 13. Okay, so now we've made our right angle with respect to the x-axis. We have defined the sides of our right triangle using the correct quadrant, the signs that we're in fact we're in quadrant 4. So we're ready now for our answers. I'm going to erase this to use this room. Um, the sine of theta, sine is going to agree with the y coordinate in sine SIGN. I'm below the x-axis. I'm expecting this to be negative. I take the y coordinate divided by the hypotenuse, and I have negative 3 over the square root of 13. I need to rationalize that, and that rationalizes, boy, it's not going to let me, well, this rationalizes to negative 3 radical 13 divided by 13. The cosine of theta is going to be positive. It agrees in sine SIGN with the x-coordinate, and if you're to the right of the y-axis, x is going to be positive. The cosine is the adjacent side divided by the hypotenuse. So this reduces to 2 over radical 13, which rationalizes to 2 radical 13 over 13. The tangent of theta is going to be negative because x and y differ in sign, and it's the ratio the y coordinate divided by the x coordinate. It is the opposite leg divided by the adjacent leg, or like I say, the y coordinate divided by the x coordinate. The way we should reduce this fraction to negative 3 halves. So now we can find the other three trig functions by taking the reciprocals. The cosecant of theta, if I take the reciprocal here, I'll get negative radical 13 divided by 3. The secant is the reciprocal of cosine square root of 13 over 2, and the cotangent is the reciprocal of tangent, and it's negative 2 over 3. There's our answers for number 2. In number 3, the directions are the same. We've got negative 8, positive 4. Negative 8, positive 4 is in the second quadrant. Go to the left, negative 8 and up 4. From the origin to our point is always our hypotenuse. We drop the angle to make the right angle with respect to the x-axis, never with respect to the y-axis. So we've got a side here of negative 8, although we don't have distances being negative, but to get the correct signs SIGN on our ratios, we write negative 8 and use that for a moment because we're going to use the coordinates to get the correct signs. Alright, so if we use the Pythagorean theorem, negative 8 squared is 64, and we've got 4 squared is 16, and so that's the square root of 80, and that would be 16 times 5, where the square root of 16 is 4. Now, if you don't want to reduce your fractions, you could scale this triangle by dividing all the sides by 4, but I'm not going to do that this time because I don't want to do steps that might confuse you. Some of you may already recognize that on the last problem, and it would just save you from reducing fractions for 6 fractions when, if you have these sides in lowest terms there, you won't have to reduce any of the fractions. You'll still have to rationalize it. And the angle is always with the hypotenuse and the x-axis. So this is our angle that we're doing. And it's important to have the right angle. So the sine is the y-coordinate divided by r. The y-coordinate is 4, and r is 4 radical 5, which reduces to 1 over radical 5, which rationalizes to radical 5 over 5. That's positive. We're above the x-axis. We're in quadrant 2, so we haven't made any contradictions. The cosine of theta, since we're in quadrant 2, the left of the y-axis, it should be a negative value. We go x over r. X is negative 8. R is 4 radical 5. Negative 8 divided by positive 4 is negative 2. To rationalize this, we have negative 2 times radical 5 over 5. The tangent should be negative because it's y over x. Y is positive, but x is negative. 4 over negative 8, and that reduces to negative 1/2. So now I can come in and find the other three ratios, either by taking the reciprocal or just knowing that cosecant is the hypotenuse over the opposite side. But usually I just think of in terms of reciprocals rather than the exact definition. So this is, if I flip 1 over radical 5, I get radical 5. and secant theta, negative square root 5 over 2, and the cotangent of theta, the reciprocal of negative 1/2 is negative 2, negative 2 over 1, which is just negative 2. Alright, so this will be the last one on this video. Number 4 here, 7, 5, that's in the first quadrant. If this is the point 7, 5, you've gone to the right 7, you've gone up 5, 49 plus 25, what is that? If we 7 squared is 49, 5 squared is 25, that's 74. And is set what's 74 divisible by? Not by 4, 74, 37. So there is no perfect square that divides 74 that I see. 37 is not divisible. So I believe this is just, unless I'm making a silly arithmetic error, the square root of 74. All right. I need this theta to be always the angle with respect to the x-axis. My right triangle is always made not with respect to the y-axis, but with respect to the x-axis. This theta is the angle between the x-axis and my hypotenuse. So the sine of theta is 5 over this radical 74, which rationalizes to 5 radical 74 over 74. All of these are going to be positive because in quadrant 1, all 6 trig ratios are positive. So I don't have to worry about negative. I don't have to worry about signs. I've got 7 over square root of 74, and that rationalizes to this. And since 5 and 74 are prime, I can't reduce that any further. Sometimes you'll be able to reduce that. Tangent is the opposite leg over the adjacent, or y over x. Y over x is 5 over 7. The cosecant, it doesn't matter, I guess, if I change colors or not. If I take the reciprocal, I get 74 over 5. Hope you can read my writing. The reciprocal of cosine is secant. The secant of angle theta is the square root of 74 over 7, and the cotangent is the reciprocal of 5 over 7, which is 7 over 5. So, hey, I hope that helps. I'll put these next ones on another video. Talk to you later.